This is Geometry, Unit 6. We are working on coordinate proofs. What we're going to do is use the midpoint, the distance, and slope formulas to prove properties of polygons. A coordinate proof involves placing geometric figures in a coordinate plane. We will assign convenient coordinates to vertices and use midpoint, distance, and slope formula to generate a proof. When you use variables to represent coordinates of a figure in a coordinate proof, the results are true for all figures of that type. Listen to that again. We use variables so that when we have different size polygons, it can represent any size, any type of number. We're going to use our distance formula, our midpoint formula, and our slope formula while we're working with our shapes. So here are your formulas. So we'll come over here. We're going to make a bit of a sketch just to give us an idea of what's happening here. 0h. 0h would imply that we're up at a height of h, wherever that happens to be. We don't really know how far it is. It's just 0h. That's A. And then at B, we're at 2g off to the side. We don't really know how far 2g is. But 2h should be twice as far in terms of a height that h was. Twice as high. So this is now our B location, which is 2g, 2h. So that's what we're working with. We're going to find the midpoint and the length of this segment AB. So if we do midpoint, midpoint, remember, is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. We often call it the average of the x's and the average of the y's. So we're going to come over to our points. It doesn't matter which one we call x1, y1, and which one we call x2, y2, but it would make sense to start with the first point we see as x1, y1, and the second point that we see as x2, y2. I can plug in my numbers. 0 plus 2g divided by 2, and h plus 2h divided by 2. So when you have 0 plus 2g, you just have 2g. When you have 1 horse plus 2 horses, 1h plus 2h, that's 3h. We can simplify one of these. We can simplify the x values here. We cross the 2's out, and that gave us g, comma, 3h divided by 2. So let's come on over. If this here was 2g, and we're supposed to come over 1g, this is a height of h this is a height of 2h. 1.5h would be right in the middle. And that's where our midpoint is. Our midpoint is G, halfway over from 2G, and up 1.5 compared to the 2H. So that's what this says. G, comma, 1.5, not 1/2, but 3/2, which is 1.5, 3/2 H. All right, now we're going to talk about the length of AB. The length of AB is going to be x2 minus x1 squared and y2 minus y1 squared. The more times you write your distance formula, the more ways you're going to be familiar with it. So we look for our x2. We see that as g2 minus 0, and we square that. (2h minus h), and we squared that. If we have 2g minus nothing, well, that's just 2g. We're squaring that. And 2h minus h. Some people make a mistake and think that that's just the number 2, but it's more like 2 horses minus 1 horse leaves you with 1 horse. So 1h squared. We can square 2g. That becomes 4g squared and h squared. Now, if we were taking the square root of either one of these independently, we could take the square root of that. But you cannot take the square root of something being added together. So we're done. You don't have to worry about the square root of this. Let's come on down to our next one. Find the length of the diagonal of a square. The diagonal is that direction. We're going to assign letters to all of the coordinate points. So if this is supposed to be a square, then we know that the x distance out and the y distance up is supposed to be the same. If we're going to look for the midpoint also, then we're going to want to find this middle location. And because we want to find a middle location, looking for something twice as long is going to be convenient. So we're going to say that this coordinate is 2a, comma 0. We could have called it 1a or just a, comma 0. That would have been fine. But then when we did half of it, we would have had a fraction. So I'd suggest going twice as far. So when we take half of it, we just have the number 1 rather than the number half. So this coordinate up here is going to be 0 right and left, but up 2a. Because a square has 2 side lengths that are the same amount. So if we go 2a to the right, we have to go 2a up. And then this coordinate over here is going to be 2a, comma 2a. Because it's 2a to get underneath it, and it's 2a to get even with the y-axis location. So those are our coordinates. So we're supposed to find the length of a diagonal. So the coordinates that we have are 2a, 2a, and it's also 0, 0. That's what we have here. So we're going to use our distance formula as, we'll call this x2, y2, x1, y1. So 2a minus 0 and 2y, which is again, or y2, which is 2a minus 0. Two a minus nothing squared and 2a minus nothing squared. Now, in a previous test that we took, when we squared a value just like this, people were very confident that we'd get 4, but 2a squared means 2a times 2a. A times a is a squared. So you got to have 4a squared. Then we've got to do it again, 4a squared, because we are squaring 2a here also. Now we have like terms. So the first time on this sheet, we have like terms that we're adding. We have 2a and we are actually a squared and a squared. 4a squared plus 4a squared is 8a squared. Now, we don't know the square root of 8, but if I break the 8 down into 4 times 2 times a squared, I can take the square root of the 4, I can take the square root of something squared, so that's 2a square root 2. I could take the square root of the 4, so that's what brought the 2 out. I could take the square root of a squared, so that's what brought the a outside the radical. But this other 2 was left inside because I don't know the square root of 2. It's a decimal. Then we look for the midpoint. So our midpoint formula we know that that's going to be x1 plus x2 squared, or divided by 2, and y1 plus y2 divided by 2. So again, if we're using these points, the 0 and the 2a, so we got 0 plus 2a, and we have 0 plus 2a. That's going to be 2a divided by 2, and 2a divided by 2. The 2's cross out, so we get a comma a as our midpoint, which should make sense because we're half the distance over to 2a, which is 1a, and we're half the distance up to 2a, which is 1a. So that's a comma a. So that's why we used 2a in this case. If we just used 1a, then when we took half of it, we'd have fractions of a divided by 2, or half a's.
What do you do when there's like 2 coordinate pairs?
Here, when we work with it, we're going to have multiple terms, and we're just going to have to look at like terms and see what happens when we can combine values. So, given quadrilateral XYZ, use the coordinate proof to show the following statements are true. We're going to show these two segments are congruent to each other. So think, what does it mean to be congruent? Is that a midpoint? Is that a slope? Is that a distance formula? What is congruent going to be? Congruent is about length. So we're going to find the length of Wx and the length of Wy, or Zy. Wx is right here. We're going to find that length, and then we're going to find the length of Yz. And they should be the same. So Wx, we know that W is a coordinate 0, 0, and X is the coordinate 2A, 2B. So we're going to plug that into our distance formula. X2 minus X1 and Y2 minus Y1. That's going to leave us 2A that's being squared, and that's leaving us with 2B that's being squared. So when we square 2A, we get 4A squared and 4B squared. And for the same reason we haven't been able to simplify that before, because of the pluses in between, we cannot take the square roots of those values. We're just done. It's as far as you can go. So now we got to compare that with YZ. Well, Z is at 2C, 0, and Y is at 2A plus 2C, 2B. A little bit more complicated here, having the two terms. But we just do the same exact math. X1, we'll consider that X2, I guess. X2, Y2, and this to be X1, Y1. So X2 minus X1 and Y2 minus Y1, and we plug in those values. So here we have 2A plus 2C minus 2C. The 2 cats minus 2 cats gives you 0 cats, or all you're left with is the 2A portion. Here we have 2B squared. And we square that, and we square this, and that's as far as we can go. And we notice that our distances are the same. Same distance shows congruent segments. The same distance shows that two segments are congruent. So did we show the segments are congruent like they asked us to up here? The answer is yes to that, because our distances were the same. Now we've got to think about this. What does it mean to be parallel? To be parallel, we have to have the same slope. Okay, parallel means same slope. So we're going to be looking for the slope, which is y2 minus y1 over x2 minus x1. So we're going to do this for wx. 2b minus 0 and 2a minus 0. That's going to give us 2b over 2a, which is b over a. Then we're going to look at the slope for zy. We do the same thing. We take the b, 2b minus 0, y2 minus y1 over x2 minus x1. Again, we have the 2a plus 2c, but we're going to minus 2c. So those are going to cross out, and we're left with the 2a. So this is 2b over 2a, which is b divided by a. So these are the same. So same slopes. Show parallel segments. And that's what we just did. Same slopes show parallel segments. Now we're going to come down here and do the midpoint. Remember that w is 0, 0. Y is 2a plus 2c, 2b. We're going to look for the midpoint of that. So that is our x1 plus our x2 over 2, and our y1 plus our y2 over 2. Well, nothing plus something is just the something, and nothing plus the something is just the something. Now, it can be complicated here also, but because we have a plus, we have to be able to divide on both sides. Because we can divide both sides of our plus, we're allowed to do that and get a plus c, comma, b. 2 goes into 2 one time. So that's our midpoint. So if you come back up here, our midpoint would be right there at a plus c, comma, b. And we can find the other midpoint. The x-coordinate is 2a, 2b, and the z-coordinate is 2c, 0. Alright. So we'll do our midpoint again. Take your x's, 2a plus 2c over 2, and 2b plus 0. Well, we can reduce what we can reduce, and we're left with the same thing we had before. Same. So they have the same midpoint. Having the same midpoint is a good way to show you have a parallelogram, because that's a property that is true for all parallelograms. Okay, this last shape, we're going to come up short. We won't finish this last one because you already know how to do this. Let's talk about it, though. It's talking about finding the midpoint of E. So you know how to find the midpoint given two coordinates. Find the midpoint to find F, which is going to be clearly going to be P comma 0. And then to show that our two lines are parallel to each other, we would have to show that the slopes are the same. And we have talked about slope. So you know how to do slopes. You know how to do midpoints. You can do this one. Give it a try.